Let's talk about Pfats and image quality. And I use the term Pfats, but I'm talking about percent intramuscular fat. The slang term is Pfats. Again, we've got our steer, the proper probe placement. This is the cord. If you want to push pause and read this, you can. And we've got a properly collected Pfat with the landmarks overlaid on the right side of the screen. Let's dive into one of the potential image quality issues. So here we have an acceptable image. We're talking about spinalis, but we don't see any spinalis in this image, which is good. We have to have less than a third of the image with spinalis, and it can be 0 of the image with spinalis. So this is an acceptable image. This image is going to be marginal. We've got a little band here. This is probably acorn, but acorn or spinalis creeping up. And the acorn or spinalis has to be less than a third to be acceptable. If it's a third to half of the way across the image, it's a marginal, and over half is rejected. In this case, this image has spinalis all the way across. So the first band is hide, and then at the top of my cursor is the top fat line. The top of my cursor is the bottom fat line, and the band between the bottom fat line and here is all spinalis. And those of you who have done meats judging know that spinalis has more intramuscular fat than the ribeye area. And the reason we have to keep it out of the image is that these ultrasound waves coming out of the probe get reflected back differently. And when we have spinalis, then we may not see everything down here the way it should be portrayed. So we can get off in how the image processes. We could place the box here, but we shouldn't place the box here. We should reject this image and not process it because the data point we get is not reliable. Now in this case, the red bar represents the field technician's probe placement, and all it is this field technician took the image too high on the animal. If they slide down, the spinalis will go away. When we talk about lumbars, I'm going to show you an image with the 13th, 12th, 11th ribs on the screen. It's acceptable. Here is a marginal image. It's got one lumbar. One lumbar is marginal. The reason, and we can tell it's a lumbar, it's wider and flatter. The reason it's marginal is there's not a lot of wiggle room on where we can place the box. The box needs to be placed between the 12th and 13th ribs, and this image does not give us a lot of wiggle room. The red bar shows that this image was collected too far back, just a little too far back. If they'd started a little farther forward, this lumbar would be off the screen and we'd have 13th, 12th, 11th ribs. In this case, we have two lumbars, lumbar, 13th rib. The probe is way too far back. The reason it's rejected and we can't process it, we can't get the box between the 12th and the 13th ribs. Now let's talk about contact. Contact is probably underestimated and misunderstood on what causes poor contact and how it affects the data. So let's talk about contact. Here we don't have any contact issues. When I look at contact, I'm looking at top fat line, bottom fat line, rounded rib tops, and scatter down here. If I have all of those, then I can feel comfortable we have good contact. In this case, here's a marginal image, and you can see what we mean by poor contact. See how the fat lines are crisp over here. We can see the rib tops. We have scatter all the way to the bottom of the screen, but over here, we lose the scatter. The rib top's a little iffy, and the fat lines are just, you can't make them out. So I would process this image because where we need to place the box, I feel comfortable with, but it would be marked as marginal. This could be fixed pretty easily by the field technician. So if you would like to push pause on this one, you can read all of this, but basically contact problems can be a result of many different things. But let's just talk about what I see and why I call it contact. So basically the fat line, top fat line is not crisp. I can see the bottom fat line, but you can see there's a lot of variation in how bright it is. The rib tops, yeah, I can tell where the ribs are, but it's really dark and there's no scatter. So this scatter down here is what tells me in the lab the difference between, is this a low marbling animal or is it poor contact? Because we would assume if this is black, it might be a low marbling animal. But because we see that it's black down here and the rib tops or the fat lines are really dim, we know it's a contact issue. So another thing I want to point out is, see this band right through here? So in this band, that's really the only place across here that we can see top fat line, bottom fat line, rib tops, and some scatter, right? So this right here is really the only place on this whole image that gives us an indication what the animal has for marbling. And this is a lot brighter and a lot more white flecks than over here. So this image needs to be rejected. The probe was placed in a decent spot, but because of contact, we're not seeing what the animal has for marbling. So this is a sample. This is an animal actually that I collected the images on its certification several years ago. I don't remember how long. But if you look at the image on the left, we were talking about top fat line, bottom fat line, rib tops, and scatter. This image is darker, right? So you would assume this animal might be lower marbling. But what was happening is the animal was very relaxed and his back was sagging. And so a flat probe was not getting good contact with a saggy back. And when I put the squeeze on the animal, this is what I got. So squeeze, no squeeze on, same shoot, same animal. That's the difference we got. Now, I think we can all see that this image is going to give us a more accurate indication of the marbling. So ribs not prominent. Okay, so this is one of the possible image quality score issues that UGC recognizes. Here's a good image. We've already talked about top fat line, bottom fat line, rib tops, scatter. So we've got an acceptable image. Here we have a marginal image. And I'm going to flip back and forth between that last image and this image, hopefully. Okay, so what I want you to see, this is the same animal. This is a canned image. So we have a good image, and we can see the rib tops are rounded and fairly crisp. And here we have an image where we can kind of tell where this 13th rib is supposed to be, and kind of tell where the 11th and make out the 12th, but the rib tops are not very crisp, right? So this is going to be considered marginal because the rib tops aren't crisp. Now here's one that I would reject because I would argue that it would be very difficult to tell where any of the ribs are for sure, or how high up they go. So if we put the box here and process it, we can get a value, but is it an accurate value? And depending on where we place the box, it's very possible that we're going to get a rib into it. So this image should not be processed. It should be rejected and no data reported. Now, I'll show you what's going on. This is an example, different animal, but this is an example of what's happening. So sometimes the field technician can rock the probe too much. If you'll notice, this probe is almost straight up and down. And the resulting image is very bright rib tops, very poor fat lines. This is not giving us a good indication of what the marbling is on this animal. It actually creates some real changes in the graininess of the texture. So on this side of the image, we've got the proper angle. So you can see that the probe is placed against the back, like the face of the probe is touching the animal all the way across, where over here there's a gap. So we've got proper angle and proper image. This is a little higher marbling animal here, but we've got scatter all the way through. The rib tops, crispness of the rib tops will be determined by how much marbling the animal has, but we can see the fat lines and so forth. So exaggeration of correct angle, but again, a field technician probe placement thing that unfortunately can come up too often. Now remember we talked about spinalis? Well, that's going to come back into play. So Sometimes narrows can be because of the animal, that the ribeye is just too small and there's no way to set this box between the rib tops and the fat lines. This image is fine. We have plenty of room. Looks good. This is what I would consider narrow marginal. You can see the scatter off the top of the rib tops is into the box, and we are hugging the bottom fat line as much as we can. So this would be narrow marginal, and again need a second set of eyes during cross-checking. We have to be careful with how much scatter gets into the box, because if we're incorporating rib structure in our IMF where we're trying to look for fat, then we can't assume that the processing is going to be correct. Now in this case, we have to keep the top of the box below the fat line. So over here we're kind of limited, and then the bottom of the box needs to be above the rib tops. So in this case, the box does not properly fit, and we need to reject this image. We could process it, but we should not process it because we're getting ribs into the box. And what's happening? The field technician is too low. So remember we talked about spinalis. Sometimes the field technicians that have gotten problems with spinalis try to correct that by just coming down. Well, there is a ideal place to be on the animal, and scanning too low is going to result in a missing data point, just as scanning too high does. So hopefully that gives you a little bit of background on some of the image quality for Pfats.